Okay, let's have the solution to example 21. For the concurrent force system shown below, determine the resultant force of the system. So let's compute the x component of the resultant, the y component of the resultant. Then there are two ways to present the final answer because when you say resultant of the concurrent force system, then the resultant is a vector. So Rx is 240 cosine 33 minus 130 times 5. So we have 5, 12, so the hypotenuse is 13. So the x component of 130 is negative. So minus 130, the x component of distance is 5, the hypotenuse or the distance is 13. So minus 130 times 5 over 13. The x component of 360 is also negative. So it is negative 360 force, component of distance 4, divide by distance, so we have 3, 4, 5. Of course, the hypotenuse is 5. So minus 360 times 4 over 5. 100 Newton force is purely downward force, so there's no x component. So that's the x component. So computing using your calculator, R sub x is equal to negative 136.72 newtons. Likewise, for the y component of the resultant, so 240 is positive, so 240 sine of 33 plus 130 times 12 over 13, then this is minus, so minus 360 times 3 over 5, and of course minus 180. So Ry is 240 sine of 33 plus 130 times 12 over 13 minus 360 times 3 over 5 and minus 180. So computing for Ry is negative 145.29 newtons. So one way of presenting the resultant is this in vector form. R is negative 136, quantity negative 136.72 I, then minus 145.29 J Newton. So you may express your final answer in this manner or the other way around depending on the instruction in the problem. So the other way around, let's solve for the magnitude of the resultant. So this is the other way. That's correct. This is correct. The other way is let's solve for the magnitude of the resultant first. It is equal to square root of negative 136.72 square plus negative 145.29 square. So in this figure here, it is already directed to the components are already negative because we have x component to the left, y component downward, but we treat the sign as negative as positive because they are obviously shown here to be in their proper direction. So the magnitude of R is equal to 199.5 newtons. That's the magnitude. Then let's solve for alpha, treating this as a right triangle with, of course, positive dimensions. But remember that the direction of the resultant should be based from the positive x-axis, then counterclockwise positive direction. So the angle should be 180 degrees plus alpha. So from the figure, tangent of alpha equals opposite 145.29 divided by 136.72. So alpha equals 46.74 degrees. So theta x is 180 plus 46.74, so 126.74 degrees. So the other way of presenting your final answer for this resultant is R is 199.5 magnitude newtons, then theta x equals 226.74 degrees. So this is the other way of presenting the final answer.